Good morning, everybody, and welcome to this month's edition of Carpe Datum Prescriptions. My name is Shirish Netke from Amaroon Inc., and I have with me Hal Stern from Merck and Company. Hal is the Executive Director of Advanced Technologies from Merck. Hal, welcome to the program.
Hey, thanks, Shirish. Thanks for the invitation. Thanks for having me on the program.
Great. So, Hal, I know that you've been in the industry for a very long time. Could you give us a little bit of your background and what you've been doing in the computer tech world for the last 20 years or so? Just give us a little bit of a background so put everybody in. Is that 20 years? You stopped counting after 10, I think.
So, for the last 3 years, I was at Juniper Networks working on architecting management and virtualization platforms, which were largely concerned around the provisioning of networks and then analyzing and extracting data from their operations to build some nice closed-loop, very highly optimized systems. Clearly, everything we do today, every data center has at least one network embedded in it, and being able to drive efficiency and control the capital costs there was certainly of very high importance for our customers. Before that, I spent a little over 20 years at Sun Microsystems and ended up in the Oracle acquisition, where the bulk of that time was spent in the field organization, a little bit of time in software and services, but my primary, I would say, functions at Sun were always around applying technology to customer problems. And I'd say that the things that certainly I enjoyed the most were picking up ideas that were resonant in one industry and playing them out somewhere else. Some of the early high availability and fault tolerance systems that had clearly been in the domain of telecommunications, we took over financial services and began the Unix migration from mainframes to Unix systems in the mid and back office. Began looking at how we would deal with web content or network content and what that meant in manufacturing and what that meant in media and publishing, and to, again, pick up some of those design patterns and carry them across industry in hopefully sometimes in some new and creative ways. And that's what my group has been charged with here at Merck, is to go apply technology to find some of those design patterns and to build them up in a fairly elastic way.
Wonderful. So you spent a long time looking at the way problems are solved in different industries and taking them across the board, across other industries. That's great. Let me ask you a question about machine data specifically. Now, machines have been generating data forever. Why is this data important now compared to, let's say, 10 years ago?
I think it's both very new and very old, which is what makes it interesting. As you point out, machines have been generating data for as long as they've had dials on them that tell us what's happening inside. And you can take that as fine-grained or coarse level as you want. Whether it's a thermometer that you'd go read and read the mercury level in and it'll tell you what your body temperature is, to industrial controls that would happen to tell you what was happening inside of a tank or inside of a process flow. The changes, I think, really come in three flavors. The first is networking, and that a lot of these systems that were standalone or were designed to be tethered at best are now networked. They know how to talk to other devices, they know how to format their data, and they're pretty good about reporting what's going on. I would say in the quantified self area, something like Fitbit, which is a tethered device. You plug it into your computer, and your computer then reports back to Fitbit.com what's going on, is a great example. And I think the lesson learned there is never, ever bet against networking. Moore's Law sort of tells you what's happening on the compute power side, but it's Metcalfe's law about the power of network systems going up as a square of the number of things that are networked is really the driving force here. And if you look at companies, I think that suffered a little bit, it was the ones let's say, from the mid-'90s to the early 2000s that bet against networking that really saw their business models turned upside down. Kodak, I would say, probably being one of the first ones there. The second part of the fact of this is we're better at dealing with scale. So if you look at all the things that could generate data and how many data points they can generate, as the compute power and the networking power have gotten better, cheaper, faster, more ubiquitous, they're throwing off a lot more data. And we now know how to persist it, how to annotate it, what to go do with it. And we can also think about it globally rather than just locally. And I think that gives rise to the third part of this in terms of why now. It's we have some of the computational tools and we have some of the design patterns to really think through what to go do with that data, not at a local optimization, not where do I go put the diapers on the store shelves in this store, but rather what's the life cycle of the buyer of the diaper? What's the life cycle of the diaper from point of manufacture to distribution to retail operation, including coupons and promotions and print advertising along the way, so you can start to get an ecosystem level view of things rather than just a particular artifact or, again, a point of particular instrumentation.
Actually, it's interesting you mentioned the ecosystem view of things. We've always kind of strived to do something like that for as long as we can remember. But is it becoming more feasible now than it was, as we were saying, 10 years ago?
Absolutely. And ecosystem has a lot of parts to it. I think you have to, first of all, have a crew of developers and a community of developers who understand the space, who are willing to add to and to enhance and to continually develop new tools. We're certainly seeing that in the big data space, whether it's Apache projects like Hadoop that happen to form the underlayment for a lot of the big data analyses, to languages now like R that are emerging to be able to ask intelligent and scientifically oriented queries about the data, all the way through now to new database systems that are graph-oriented rather than table-oriented, to understand that the power of a lot of these relationships is the way in which the data are linked to each other. It's understanding that an entity in one is actually related to an entity in the other. Mm-hmm. And if you're putting things in tables, you say, oh, inner join, Cartesian product, and you know, some database expert somewhere will be very happy that you remember that from college days. Yeah. But it's the non-tabular view of the data in terms of how do we extract things and form these interesting graph relationships that walk the graph that gives us some of that power. So, you know, ecosystem comes in a couple places. Developers, it's practitioners who understand what those relationships are and how to go look for them. So it's data scientists who really get this. And then the other part of the practitioners, people who understand scale and who are able to drive scale up and scale down, and our ability to build elastic solutions, I think, is the other part of it. If you have an idea for an algorithm that really requires 500 or 600 cores of compute to give you an answer in a short enough time window in which it is an effective and actionable answer, you may or may not want to go buy 500 or 600 cores of compute. You may want to go do that on a public cloud provider because you only need them for an hour. Right. And it's well worth it to you to get those 500 compute hours once a week, once a month, whatever it is, rather than to have them in-house all the time. And that dial up and dial down, I think, it's another one of those artifacts of scale we've gotten to. It's scale up and scale down, I think, that are driving some of the efficiencies here.
So scale is something which we couldn't do before and we can do right now. You mentioned something about graph databases and link analyses. Is that kind of the applications which people are looking at right now into the future as being more promising in this age of scale and big data?
I think it clearly it's understanding the correlation type patterns or understanding the relationship type patterns. You know, I'm a big fan of the O'Reilly Web 2.0 architectures book, and in there they discuss what some of the common web data patterns are. Right. And you know, things that are correlated or causation. Very clearly, the triangular patterns. You know, you understand two sides of the triangle. What's the third side that's missing? How do I go find that? Right. Very clearly, those fit to the domain of what to go do with the big data. What I think is driving them, however, is are two forces. Mm-hmm. One is that we're becoming perhaps less afraid of unanticipated use. Mm-hmm. As we build a system and people start asking questions of it that we didn't plan on them asking. Right. We put data into it that we didn't anticipate being in the system, mm-hmm. and it broadens the domain of those types of correlations or causal relationships that we can go discover. Mm-hmm. And we're hit by that. We didn't think of that before, and that's cool because it drives scale, but it also in a lot of cases drives insight. Very clearly, I think it's our ability to go think about all of our different data sources or where the data is coming from, and to find those relationships. But one of the drivers for it is this notion of unanticipated use. That is that there's data coming into the system or questions are being asked of the system that we didn't think about early on. And the best example I can give you is one that Tim O'Reilly frequently mentions, is about Twitter and hashtags.
Right.
If you were to go off and build a hashtag system, let's say you decide you want to design a thing, you would have spent ages building a taxonomy and an ontology and dictionary, and here are all the keywords, and you never would have thought of having a tweet that was really bad day at work, hashtag back-to-back meetings with no breaks, couldn't even eat lunch. Because no one would have actually thought of, well, who on earth is going to have a hashtag where the hashtag's 3 times longer than the subject?
Right.
But it creates a context, and it creates some metadata that allows you to interpret exactly what the mood, the feeling, all the other, you infer so many other things about what the content was there based on the hashtag. Being able to have that unanticipated use that was never designed into Twitter from the beginning, but it actually is the way now in which they aggregate content, the way in which they can sell ads around the content, it's the way in which people search for content. It's become, I would say, the definitive way in which Twitter is an informing tool rather than a micro content management tool.
Right.
And that was completely unanticipated. So there's, and underneath that is a whole set of graph relationships, which is how do you find tags that are related to each other, which ones are recommended, which ones might you be interested in. You search for this hockey-related theme, and you live in New Jersey. Maybe I want to show you hashtags that involve the New Jersey Devils and the New York Rangers, as for example.
Right. It's an interesting concept that you can actually, you don't have to think about what you're going to do with the data when you're collecting it. That's a luxury which we didn't necessarily have for a long time.
Right. Well, you don't want to think about that. At the same time, you don't want to lose any of the richness of it, and it's another artifact of scale.
Yep.
Is that
yep.
It's sometimes tempting to say, well, let's just go get the core of it and where it came from, or what else we know about the user at the time, or what other annotation. Not really that important. We just want the bits.
Right.
But it is those things that become important. And if you pull us back to the area of machine data, we tend to think of machines operating in essentially standalone, isolated things, but they are so intimately connected to the rest of our infrastructure, whether that's HVAC or electrical or even people systems, that understanding something about that, understanding how a machine operates and what its quality of output is as a function of weather. Well, if I know something about weather, I know something about the electrical demand in the area. I know something about what the load is like on the electrical system. I can make inferences there.
Right.
And start to look there and see, do I actually have problems with power distribution? Do I actually have problems with, from a global scale, with machine efficiency when I'm perhaps getting a lower quality of power than I was before?
Yep.
Under a time of less global demand. And those again, it's sort of an obtuse example, but it is an example of context that you wouldn't normally think to collect, but by collecting it and adding it to the mix, you allow for other sorts of analyses to be run. And just a big driver of scale, the big driver of these causation patterns.
Yeah. So now let's get into something like more concrete, like applications of big data from an economic point of view. Now, there's a lot of discussion around productivity when it comes to big data and all. So, is there really so much money to be made, or is there so much of an economic imperative to make sure that truck drivers don't avoid left turns and minimizing jet fuel consumption and all that stuff? Hasn't this already been optimized to the nth degree over the last several years?
It has been on a local scale.
Okay.
And I think that the risk here is we don't want to get stuck in the local minima. And if you remember back to your
the global optima,
you had to go find the zeros and the zero derivative points of a curve. There would always be those little tricky questions where the curve would have a dip in the middle. No, that's the local minimum. It's not the global minimum, the global maximum of the value of the value equation. And let me compare truck drivers avoiding left turns to something like Uber as a taxi dispatch service.
Okay.
Uber collects data, effectively machine data. It's collecting GPS data as well as some knowledge of the driver. So you have a rating for each driver. You know where the drivers are. You know what the demand is in the area, so you can set variable pricing. When there's high demand, the prices go up.
Okay.
And it allows you now to start planning. Rather than standing on the street corner, randomly waving your hand, hoping a taxi comes by, you know where they are. If it pays you to walk a few blocks to avoid traffic, because it will allow you to get a taxi faster, that works. If it allows you to choose a different size of car because you're going to consolidate passengers. That works, and it puts the decision power into the hands of the consumer, as opposed to the decision power really being either in the hands of the dispatcher or a complete set of coincidences in terms of you have to be standing where there was supply at the time when you had personal demand for it. And that's a global maximization problem. It takes a lot of local minima and looks at them through the power of networking, through the power of scale, through this power of patterns to figure out how exactly do I go match supply and demand, and how do I possibly change the economics of it, if I'm oversold or overbought.
So you mean there is an opportunity right now because of this ecosystem approach that you talked about to do a better job at the global maximization as opposed to global optimization, as opposed to figuring out the local what's best local.
And that's the challenge. I talk about finding these graphic relationships. I think the challenge in those is understanding what the supply and demand axes are, what the supply and demand units are, and how they have elasticity or where they have market elasticity that you could modulate by getting better data and by better understanding the shape of the supply or the shape of the demand, so that whether it's machine data or sensor data, however you want to look at it, or even GPS data as a corner case of that, will allow you to start building those models, and then to go from the local view of it into a much more global view where the global optimizations, either they create markets that didn't exist before, like Uber, or they allow you to do optimization on a very, very different scale.
Okay.
Anybody in the Bay Area will tell you that they'll check their phone. Their phone tells them the best route to get to work each morning,
right,
based on traffic, accidents, local events, whatever. And that's it's still local area, but it is better than the complete local area optimization, which is you drive till you see taillights, and then as soon as you come to a stop, safely, of course, you take out your phone and see where the accident is.
Yeah, that's the older method.
Right. And what that does is that removes congestion that would have built up behind the accident or behind the work area, and it actually helps resolve the congestion faster. So you're having everybody's net time to work goes down as a result of that, which has nice environmental impacts, it has nice cost impacts, and generally as a quality of life thing goes, it's better for everybody. So simple example, but one that we're seeing more and more, and it's based on this. Let's go look at things from appropriately high up.
So what you are saying is that there is there is still an opportunity to optimize further on truck drivers and jet fuel consumption, which can save us a lot of money, increase productivity.
Absolutely, as well as I would say a large number of markets that here that haven't necessarily gone too far into the big data space, or are thinking about what it means, and whether that's increasing personalization or again other ways of matching supply and demand. I think there are opportunities there for us to continue to go drive the patterns and continue to go drive the adoption. And that's, you think about this picking up of strategies that worked in one market, taking them to a different vertical. Clearly, big data has been at play in the risk analysis area, so in financial services, in the personalization area, in terms of content delivery on the network. Companies, whether it's YouTube or Netflix, deciding what they want to show you next, there will be opportunities to apply those patterns, I think, in other places. And those patterns will be enhanced and enriched by the types of data that we're able to get. And if you want to, without sharing all the secrets, if you want to get a sense of it, take a look at what's happening in our ability to quantify data about ourselves, whether it's 23andMe or your Fitbit, or this wide array of wearables that come out to tell you, what your blood pressure is. All of them are giving us a better sense, and sometimes with a highly variable quality, with a better sense of what do we know about ourselves. That's data that we can use to go feed into some of these equations.
Yeah. Now you mentioned earlier about your experience across multiple industries over the years. Now, specifically as it relates to big data, are there any industries that you think are doing a much better job of taking advantage of industrial big data than others? Are there kind of examples that you can point to right away on, say, these guys are ahead of the others?
I would say clearly it's been the social media, so anything that involves building graph relationships, deciding what to show you or where you may be interested or what you don't know yet. And that's in, I would say, some of the online learning, digital learning spaces, which is a variation, if you will, of social media. And then very clearly, I would say that the financial services firms have done a good job of understanding risk and understanding elements of risk here. Mm-hmm. The cautionary aspect I would offer on that is almost every one of those things is a trailing indicator. It's based on
after the fact,
what you've already done and what you've already bought or what you've already clicked on, and you're trying to, based on that, infer what else might be interesting. Mm-hmm. And the opportunity ahead of us, I think, will be to have some sort of leading indicator or predictive indicators. And it's going to be a function not just of data, but of data and user experience. Mm-hmm. And the other thing that will come to bear on big data is and this is if we've had machine data for a long time, we've had human-computer action for even longer than that. Yeah. Neil Stephenson, in the beginning, there was the command line. Well, we can go even further, than that. In the beginning, there were toggle switches.
Right.
As we have evolved our user experiences around this to think about what data we capture, what data we generate, and how exactly we quantify or improve its quality, there are opportunities as well there to take lessons out of the design space, out of the UX space, and bring them to bear here. And hopefully that combination of things, better design, better quality data, and picking up design patterns from outside of the classic data reduction space will hopefully give us some leading indicators.
Yeah, so can you give us some examples of technology companies who are actually leading the way in this area?
I tend to hold up the big three, mm-hmm. Twitter, Facebook, and LinkedIn.
Yeah.
Both because of the scale they're dealing with, as well as some of the things they have contributed back to the developer communities.
Right.
Thinking about the tools and the way to go look at some of the way you build a highly scalable, highly elastic environment mm-hmm. for this. On the other hand, they all tend to fall. Those three tend to fall into the same bucket, which is they look at graph relationships of people,
right.
People and their interests, and try to make recommendations or connect them a little bit better.
Right.
I would say the other market I would look toward, and mm-hmm. they probably talk about this less, is in the telecommunications space.
Right.
Almost every one of the service providers has had network data,
right.
And they have network data, whether it's at the radio towers on the cellular side, or at the backhaul points, or at the metro Ethernet edge, or in their core, and they're able to build very, very elaborate operational models. So it's not a people topology, it's a network topology that they can actually change. It would be cool if you could say on LinkedIn, well, gee, all your LinkedIn results are colored because you have to be connected to these three people. If you just didn't like them as much mm-hmm. or weren't connected to them, we'd have this whole other set of things we could do for you. You have that opportunity in networking space to go change it. It creates interesting modeling problems, interesting predictive problems. And I guess the other learning to come out of this is whenever you start talking about walking a graph and looking for things that are graphically related and possibly topologically similar, the problem space gets really large really quickly. Mm-hmm. It's exponential in size.
Right. And
some of the algorithms that you might apply sort of as a very first pass, very, very quick approach, I think then you have to worry about running into some of the problems that are intractable. They're just way too computationally complex. So the other part of that is, let's go back and look at then what are the simplifying assumptions, what are the approximations, what simulations could we do to come up with some data as well, come up with some predictive results as well. And this is one where you look at AT&T back in the 70s and 80s, mm-hmm. they consumed an awful lot of math PhDs because they were thinking about these problems. Again, what do you go do with the data? That time it was called data, called detail records. What do you go do with the data to make operational predictions so that phone system always worked?
Yeah, so actually the telcos have been thinking about an ecosystem approach or a holistic approach for a very, very long time.
They had to. I mean,
mindset.
And part of it was that people had a certain assumption of quality, which is when you picked up the phone, you had dial tone.
Right.
And except in very, very rare cases, like when you're trying to be the 100th caller to the New York radio station, you got through on the first ring.
Yep.
So.
Yeah. So that sort of brings me to the next point. And I mean, if you look at it from of how enterprises can take advantage of these technologies. Now, what does it take to convert, let's say, a hypothesis on causality or correlation to a productivity increase? And so basically, how do you take something which is a hypothesis and convert it into a business practice which has a direct impact on the bottom line? Because we're always afraid of all these science projects which go nowhere.
Well, I think that what you said, the operative word there is process. That you want to understand what the process is.
Yeah.
And I think there are a few steps in going between a toolbox of technology into some commercialization of that idea. And the first thing is you really want to understand the observability of the process. What's the quality of the data, and what's the quality of the action you can take? You know, if your goal is to be able to change a particular variable or be able to change a part of the process, will that have an effect? So just you have that end-to-end observability and you have some notion of what the relative quality of the data are. And if any of those things are dubious, what do you do to improve it? What other correlating or corroborating sources of data can you pick up that would help there?
Okay.
The second thing then is to understand what the entities are that are the principles, if you will, in building the set of graph relationships. What are the things that matter? What are the nodes in your graph, if you will? And then to start using the tools to extract them and build the relationships among all those different nodes. So, you know, how do you build a good graph? How do you build a good mapper, if you're in the MapReduce world, to do the extraction and fill in the edges of your graph? And out of that unanticipated use problem may pop out there, where you start finding edges you didn't think you were going to have, or the graphs are much richer, much more dense than you would have thought. You're seeing the artifact of an unanticipated use. And then finally, I think it's got to be a question that has a very clear boundary in terms of knowing when you're done. And that you're able to specify, at this point, with this level of confidence, or after this many runs, or after the results stop changing by epsilon, we're good.
So marginal
we'll
returns.
Try it out, and we'll close the loop at that point.
Yeah. So you got to know when you're getting marginal returns and stop and get to implementation.
And, if you're getting marginal returns and it's costing you more CPU or hours more compute or lots more data, and the results just aren't improving at all, don't bother.
Yeah.
But again, at some of the, at the same time, I think that the part of that understanding is first understanding what was the impact you were looking to have. So you said, well, we put another 20% of compute at it and we only got a 5% return. Probably not worth it.
So now, Hal, you've seen a lot of technology adoption cycles over the years. So let's talk a little bit about big data adoption in that context. Have you seen this movie before, and do you know what's going to happen next?
If I did, I'd be on the investing side, not on the applying side. I think as you look at market adoption, though, and adoption of technology, everybody likes to point to things like the Gartner hype cycle, and point to where the build a. Let me step away from that. I think the couple of things that immediately leap out at me. The first is, while we are always lucky or fortunate to be able to pick up an aspect of one market and bring it to a new one, it's possible to over-rotate. One of my favorite conversations with one of the New York banks involved, what do you do if there's a failure in recording trades at market open? How do you go and essentially reconcile the trade book?
Yeah.
And we had discussed a very, very elaborate 5 nines of availability, fully replicated system that got very, very complex very quickly. At some point, one of the key business people said, well, if we ever think that there's a trade that might have been processed, but we're not really sure where it is in the trade book, we just call up the operations desk and they tell us what crossed and what didn't. And we all kind of looked at each other and said, all sorry, yeah. You mean like a phone call? Like, yeah, at some point making the call is bad. And we were sitting there thinking about what our latency would be for doing replication and how many systems we would need and where they would have to be. And someone said, no, it's okay if it fails as long as you can recover from the failure quickly.
Yeah.
So the first thing to look at here is realize there will be failures. There will be failures in data quality. There will be failures in data collection. There will be failures in networking. Make sure that the system we build has the right level of availability and certainty at the right level of abstraction.
Mm-hmm.
The more, and this is particularly because we're starting to get into the machine data.
Yeah.
It's great to have sensors until there's a leak and the sensor gets corroded. And then if you're expecting that sensor to be giving you data in real time and it failed, oops.
Then you're done. Yeah.
So you don't want to over-rotate on the hardware side if it's really service reliability that you want, and therefore service analysis quality that you want. Then I think you have to pick the level of abstraction and understand how you make that level of abstraction reliable. That we've seen that, I would say, again and again and again. The companies that have exceeded its scale have done so because they thought about reliability at a much higher level.
And they probably stayed, and they probably stayed focused on the objective.
Too, which is it's also possible to have way too much data.
It is.
And there's a tendency then to start making hypotheses that may or may not be strong and backfitting the hypothesis or the analysis to the data, which is it's a dangerous thing. We want to look not just at the level of abstraction of our systems, but the level of abstraction of the decisions we're making. And yes, if you go looking for very fine-grained data and filter it very carefully, you can find things that aren't there. There's Randall Monroe has a fabulous XKCD cartoon of someone looking at the FedEx logo, looking for the arrow between the E and the X in FedEx, and instead they see someone in a Guy Fawkes mask because they're seeing lines that aren't there. The XKCD number 890 is one of my favorites because it gets it in one that if you are not sensitive to the quality of the data and the noise in the data, you don't want to start building systems that amplify the noise. And that's a lesson learned from way back. One of my old thesis advisors, who was one of the very first electrical engineers to make the crossover from analog to digital systems, always used to say that even if you're dealing in a digital system, it's all ones and zeros, it's electricity underneath it, which is analog. And if you don't understand noise and circuit design and all the other things that can introduce problems into that digital system, your digital systems won't work. So you have to be sensitive to the noise here. Again, it is digital, it is digitized, but there's noise there. When you're dealing with real world phenomena, there's noise, and you have to understand how to deal with that.
And so there are dangers in over-analysis.
And then I guess the final, what do you worry about is, as we look at things, again, when we're looking at a local problem, okay, I have one data set, I'm going to analyze it, I'm going to optimize it. Here's the best place to put the diapers on the shelves. Here's the streets to avoid at 5 p.m. if you're driving an 18-wheeler, those sorts of things. On a more longitudinal view, when I want to look at data across a long period of time or across a broad swath of users, I want to understand my data flows. And if I'm a graph theoretician, I start looking at cut sets. As if I divide the graph into two pieces and look at the edges that cross between those two subgraphs, what's going in or out?
Yeah.
And that will give me a sense then of where I place it, what I can observe about it. In some cases, if those sets have to do with regulated and unregulated, or high quality and lower quality, or derived data, or imputed or sensed data, that will help me also put things into equivalence classes in terms of their reliability, my observability, what I want to do with it. In other cases, it may force some attention in terms of, well, where exactly can you put it? Whose data center does it have to live in? Because there's some other operational restrictions around that data.
Right. So, in fact, at the end of the day, you still have to focus very rigorously on the business objective and what are you getting out of it, and and be kind of careful not to go down the path of science projects too much.
Absolutely.
Yeah. So, Hal, I think we are almost out of time right now, and one of the questions we always ask our guests is what your carpe diem prescription would be for enterprise CEOs today. What's that? What's there? If there's one piece of advice you could give to our audience who are dealing with, who are enterprise leaders who are dealing with how to use this technology for the future, what would be that one piece of advice be?
Narrative is very powerful, and tell me the narrative of your data. That is, tell me where it came from, how it was used, and what its provenance was in making a decision. And if you're good at that, and you can express that story fairly simply, you gain a lot more attention around the answers, and people use the answers because they are quick to repeat and understand the story. And B, it should have a higher level of confidence that you truly understand the provenance of what you've come up with, and how that big data analysis has worked to your advantage. If there's not a narrative around it, again, at some point along the way, there's a step where a miracle is implied, or it's just not transparent enough. And they will either drive down confidence, or in some cases, introduce unanticipated results of the negative kind. So the best thing I can say is, as you look at this, at the universe of data that we can collect, and the now growing array of tools to which we can apply analyses to that data, they're telling a story. And yes, technical stories aren't all that exciting. They don't have car chases or explosions or interesting sleights of hand in them. But there is definitely a narrative in there of the data, and the more simply it gets expressed, usually the more powerful the result is.
Okay, that's great. That's actually a fantastic piece of advice, to focus on the story and the narrative. So, Hal, that's all the time we have for today. Thank you very much for participating, and I'm sure there'll be a lot of questions which we will take offline and on email and on Twitter. Hal, thank you very much.
Okay, thanks for having me. Take care.
All right, great. Bye.